9. This question is from biomolecules chapter. So they have given us the specific rotation of a L-glucose and L-fructose, which is minus 52.5 degree and plus 92.5 degree. And we have to see which of the following statements are correct. And this is multiple correct, so more than one option may be correct. So first they have given, on treatment with HNO3, gluconic acid is oxidized to saccharic acid, whereas glucose is not oxidized to saccharic acid, which is wrong because glucose can get oxidized to saccharic acid. On reacting glucose with the concentrated HNO3, what we get is glucaric acid, or we can also call it as saccharic acid, which is possible. But in the options they have given is glucose is not oxidized to saccharic acid, which is wrong. So option A is false. Next, option B, fructose gives positive Fehling's test because it isomerizes to glucose and other aldohexose in the presence of Fehling reagent. So Fehling reagent will basically answer the positive test for glucose. So the option B is true, because glucose gives positive test with Fehling solution. So this is correct. Next, option C, inward sugar is an equimolar mixture of D-glucose and D-fructose formed after hydrolysis of corresponding disaccharide, which is also correct. And D, they have given us specific rotation. So if we calculate the specific rotation which is given in the question, so we'll calculate minus 52.5 plus 92.5 divided by 2. If we do, we get 40 by 2, that is plus 40 by 2. So we will get plus 20 degree. But in the question they have given us minus 40 degree. So statement D is false. So true statements are B and C for the question number 9.
Hello students, we have paper 2, question number 10. The question says there are two species, hydrogen-like species, X and Y. The X has a charge A plus, Y has charge B plus. Okay. Then the wavelength of the light absorbed for transition between the states 1 and 2. So your transitions from 1 to 2. Wavelength absorbed is given as lambda. And the transition for Y B plus, the transition is being said to be happening between, to the question, 2 to 4. And the corresponding wavelength of transition is given as 9 lambda. Okay. And we are asked to find the lowest possible value of A plus B. Lowest possible value. Okay. So we shall use Rydberg formula to calculate the wavelength and then compare the wavelengths for these two species. The Rydberg formula for wavelength and wave number is Rydberg constant 1 over reciprocal of wavelength, Rydberg constant times 1 over n1 square, here n1 is 1, its square, minus 1 over n2 square, the higher value of n2, 2 square, into z of x and its square. Okay. In the same way, the reciprocal of wavelength, which is 1 over 9 lambda, should be equal to Rydberg constant times 1 over 2 square, which is 4, minus 1 over 4 square, which is multiplied with its atomic number z y square. Right? Okay. Next, this bracket term simplifies to 1 minus 4, which is 3 by 4. Okay. So it is RH into zx square into 3 by 4. On the other side, the RHS simplifies to RH into zy square into 1 over 4 minus 1 over 16. Taking LCM here, we have 4 minus 1, which is 3. 3 divided by 16. Okay. Now you take these two equations, divide the second equation, or divide the first equation by the second equation. Okay. So dividing first equation by second equation, you get 9 on the LHS. 1 over lambda divided by 1 over 9 lambda, that will be equal to 9. RHS, the RH value cancels, and then 3 by 4 cancels there. RH RH zx square into 3 by 4 whole divided by RH zy square into 3 by 16. This RH term cancels, the 3 cancels. What remains is zx square divided by zy square, okay, into 4. Shifting this 4 from RHS onto LHS, we have zx divided by zy square equals 9 by 4. Taking square root on both the sides, we have zx by zy equals 3 by 2. Okay. So for the nucleus to have 3 protons and yet to behave like single electron system, the charge A should be equal to 2. Okay. So this nucleus is lithium and its charge should be 2 plus to behave like single electron system. And this nucleus is helium and its charge should be 1 plus to behave like single electron system. So this charge A and B added becomes 3. So that's our answer, 3. Okay?
So we are doing question number 11. So at a given temperature, 0.45 gram of acetic acid in 50 ml of water is shaken with 1 gram of charcoal and the pH of the resulting solution is 3. Okay. Now assume the absorption of acetic acid from the aqueous solution by charcoal follows this equation. X by m, K, C, 1 by n. Okay. If the plot of log x by m against log c gives a straight line with slope 1, the value of K in liter per mole is, we have to find. Now we are doing solution. So 1 by n is equals to 1. N value we have 1. Okay, if just put the value of n in this equation. So we have x by m is equals to k c. Now we want to find the k value. Okay, so x by m is equals to k, or you can write x by m divided by c. So this is how we can calculate the value of K. Now, in the question we have given acetic acid which is 0.45 grams. Okay, and we know that the molar mass of the acetic acid is 60. So with this we can find the number of moles of acetic acid. How to find the number of moles? Given weight divided by molecular weight. So given weight we have given 0.45 divided by 60. It should come around 7.5 into 10 raised to the power minus 3 moles. So these are the initial moles for acetic acid. Okay, now we have given pH value also. So with that we can find pH value is 3 we have given. So if you want to find the concentration of H ion, that should be 10 raised to the power minus 3. Okay, now we know that is equals to root Ka into C. That is the formula. Now you can put the value of HN, that is 10 raised to the power minus 3, and we have given the Ka value also, that is 10 raised to the power minus 5. Ka value is 10 raised to the power minus 5. Under root 10 raised to the power minus 5 into C. So 10 raised to the power, this is squaring, I am taking this side, so it is square 10 raised to the power minus 5 into C. So from this we are able to find the concentration of the acetic acid. Is equals to, which is 10 raised to the power minus 1. So 0.1 molar. Okay. Now we have the concentration. This is the concentration when Ka is 10 raised to the power minus 5. So if you find the initial concentration, that should be N by V. What is the number of moles? Number of moles we have given initially this 7.5 into 10 raised to the power minus 3. And what is the volume we have given? 0.05 in liters. Okay, so if you divide these two values, you got 0.15 molar. That is the concentration initial. And this concentration is, we got, and final. Now, and final we have to find. So just do C into V, because we know that concentration is N by V. So if you want to find the number of moles, which is final, so you have to multiply concentration with V. So it is, what is the final concentration we have? 10 raised to the power minus 1 into, what is the volume? Volume we have given 0.05. So final moles we have 5 into 10 raised to the power minus 3. This is final moles. Now we are calculating the mass. The mass which is remaining. We know that number of moles is given weight by molecular weight. So we have to find given weight. That is number of moles into molecular weight. So number of moles we got 5 into 10 raised to the power minus 3. And molecular weight 60 for acetic acid. If we multiply these two values, we got 0.30 grams. Okay, now, and initially the mass of acetic acid is 0.45 we have given. Yes, 0.45. Now, the mass which is absorbed, 0.45 minus 0.30. So X value will be 0.15. Now, we got the X value. Now we want to find the mass of charcoal. That is already given. Mass of charcoal is 1 gram. Okay. Now, X by M value we have to find. Okay. X by M value is 0.5 only. 0.15. Now, C value we have, X by M value we have, just put the values. 0.15 is equals to K. C value we have 0.1. So K value we have 1.5 liter mole inverse.
Okay. Now, students, next question is from paper number 2, question number 12. Paper 2. Question number 12. Okay. Here we are being provided with a solution of a compound B in a solvent C, and it is said to be dissociating to two products. In the proportion 2:2. Okay. Next, in this question, the solvent is said to be S, and then let us list out the given conditions. We are also having the condition in terms of molar mass. Okay. Molar mass of solvent and molar mass of solute. Solute is said to be 10 times in molar mass to that of solvent. That's first condition given. Then boiling point of solvent is given as 400 Kelvin. Then one more data what we have is enthalpy of vaporization. Enthalpy of vaporization given as 10 times gas constant joules per mole. 10 times universal gas constant joules per mole. Okay. Then the solution of B at a weight percentage of weight by weight percentage of solute B is given as 0.25%. Okay. This particular solution's boiling point of solution is given as 408 Kelvin. Using this boiling point of solution and comparing with the solvent, this is a problem related to elevation in boiling point. Elevation in boiling point is 8 kelvins, 8 units. Okay. And we are supposed to find the degree of dissociation in percentage. Okay. We are supposed to find percentage degree of dissociation, percentage alpha. Okay. Now to solve this, we need to find the Van 't Hoff factor, because we know the Van 't Hoff factor is 1 plus n minus 1 alpha. Okay. So if you know the Van 't Hoff factor, alpha can be obtained. Okay. Towards finding the Van 't Hoff factor, we shall be using the equation ebuloscopic, the elevation in boiling point as I times Kb into m. Okay. So for those things, I need to first get the value of Kb. Kb value is directly not given here, so we can use the thermodynamic relation of Kb with molar enthalpy of vaporization, which is R T naught square into molar mass of solvent whole divided by 1000 times enthalpy of vaporization. Okay. Now this R into the T naught square, we have it as 400 Kelvin and its square into molar mass of solvent. Molar mass of solvent whole divided by 1000, and enthalpy of vaporization is 10R. Okay. So over here the R term cancels. So this gives us, we shall even replace this molar mass of solvent in terms of molar mass of solute, because in comparison with molality, we'll be using the molar mass of solute. Solvent's molar mass is 1/10 of molar mass of solute as per the given condition. So we have 400, which is square whole divided by 1000 into 10 into molar mass of solute divided by 10. Okay. So simplifying this, it becomes 16 molar mass of solute divided by 10. So which is 1.6 into molar mass of solute. That's the Kb value in terms of molar mass of solute. Okay. Next, Van 't Hoff factor using the colligative property, that will be equal to eight kelvins as elevation in boiling point equals Van 't Hoff factor into ebuloscopic constant, which is 1.6 times molar mass of solute into molality. Molality is moles of solute, which is if I take 0.25 grams in 100 grams of solution, 0.25 grams in 100 grams of solution. That's what we have in question. 1 second. 0.25 percentage mass by mass. Okay, so that's 0.25 grams converted to moles by dividing with its molar mass of solute. Okay, whole divided by kilograms of solvent. So now if I assume the exact mass of solvent here, it will be 99.75 grams. 99.75 grams. To round it up, assuming a dilute solution, it will give a different answer. Okay. So 99.75 grams of solvent into 10 to the power of minus 3. So that will be in kilograms unit. So this molar mass of solute gets cancelled. Your Van't Hoff factor will be equal to 8 into 99.75 into 10 to the power of minus 3 whole divided by 1.6 into 0.25. Okay. So cancelling of this, if I take it as 8 into 99.75 whole divided by 16 into 25, shifting this 10 power of minus 3 to denominator. So this 8 cancels 2 and 2 into 5, 25 is 50. So 99.75 divided by 50, which is 100 divided by 2. You multiply the numerator by 2 and divide it by 100, we'll be getting it as 1.995. Okay, so this will be the accurate value of Van't Hoff factor. If we go by the rounding up idea, so your 8 will be equal to Van't Hoff factor into 0.25 divided by molar mass of solute whole divided by, in place of 99.75 grams of solvent, if I assume it as a dilute solution and take the entire mass of solution as solvent's mass, approximate, it will be 100 grams converted to kilograms with the factor 10 power of minus 3. Okay, so here simplifying, you will be getting Van't Hoff factor equals I forgot this I into 1.6 times molar mass of solute. Okay, so this will be 8 into 100 into 10 power of minus 3 whole divided by 1.6 into 0.25. Okay, so in the same way, if we simplify, it becomes 2 times 25, which is 2 times 100. I value becomes 2. So that's the difference what we have. If we assume dilute solution, I value is equal to 2. If I assume the actual concentration of given solution, I value is this much. So to get an accurate answer, I will replace this I with 1 minus n value. N value here is the number of particles into which a single molecule of solute dissociates. 2 particles of C and 2 particles of D, total of 4 particles. So it is 1 plus 4 minus 1 into alpha. That will be equal to 1.995. Okay, so this 1 plus 3 alpha becomes equal to 1.995. 3 alpha equals 0.995. So alpha on calculation, you get it as 0.33167. Okay, and percentage and rounding up to 2 decimal places, it becomes 33.17. On the other hand, if you consider dilute solutions, the alpha value will be equal to I minus 1 divided by n minus 1, which is 2 minus 1 divided by 4 minus 1, which is 1 divided by 3. In terms of percentage, it will be 33.33. Clear? So that's it.
that they are the coordination atoms, coordination a compound having chlorine and nitrogen atoms. In the complexes cis CONH3 4 times Cl2 and meridian CONH3 Cl3 complex. There are two complexes given. One is cis cobalt NH3 4 times Cl2 Cl. Here one complex is there. Another complex CO NH3 3 times Cl2. This is another complex. This one meridian complex, this one cis complex. What he is asking means, in these structures, a triangle in which there should be 2 chlorine atoms and 1 nitrogen atom. Such kind of triangular faces, how many are there in the compound? They are asking that. So the triangular faces having 2 chlorine atoms and 1 nitrogen atom. Such kind of triangles, how many are there in the compounds, right? So first of all, if you consider CONH3Cl2 complex, right? So it is an octahedral, both are octahedral complexes. So therefore you have to write first octahedral structure of the compound. Octahedral structure of the compound CONH4Cl2, cis compound I am going to write here. Cis compound I am going to write. So in the cis compound means the 2 similar ligands. Which are 2 similar ligands? Those ligands should make the 90 degrees angle. So therefore here 1 Cl, here 1 Cl. Remaining 4 NH3 groups I am going to write NH3, NH3, NH3. There are 4 compounds, right? Now give the numbering to this one. 1, 2, 3, 4, 5, 6. Right? Now there should be 2 chlorines. There should be 2 chlorine atoms and 1 nitrogen atom. Such kind of 2 triangular places you need. So 2 chlorine should be there, means compulsory 1, 2 you have to take, right? So for this one 1, 2 compulsory you have to take. This is 1, 2. Right? Where is the other nitrogen, 1 nitrogen atom here? 1, 2. This is 1 nitrogen atom. What we shaded now here? This shaded triangle will be there like this manner. In this 1, 2, 3. So 2 chlorine atoms, 1 nitrogen atom. So 1, 2, 3. There is a triangular face which contains 2 chlorine atoms and 1 nitrogen. One more. Why 2 chlorines compulsory you have to take na? So therefore 1, 2. So 1, 2 and another nitrogen. Another nitrogen means such kind of triangle where it is there. This is the another triangle. So this is the another triangle 1, 2, 4. This is the another triangle. So there are 2 compounds such kind of triangles, right? In this compound 2 are there. Now what about the meridial CONH3 thrice Cl3? This is Cl3, not Cl2. Cl3. So this structure meridial compound you have to write. Okay. So in this one, first of all write down octahedron for this compound. Write down octahedron for this compound. Cobalt, right. Now if you observe the meridial structure means 2 Cls should be 1 axis and 2 Cls should make the 180 degrees angle, and the NH3 and one more Cl should form a right angle triangle with that 180 degrees angle. That means here 2 Cls you have to take. These 2 Cl ligands makes 180 degrees angle. Another Cl should make the 90 degrees with this angle. Then this is the meridian form of the 3 Cls. Similarly NH3. These 2 NH3 groups, 2 NH3 with 180 degrees. Third NH3 makes 90 degrees angle. This line, this ligand bond with the cobalt makes a 90 degrees angle with these two NH3 bonds. Then the structure is said to be meridian. Then what we have to do here? Chlorine atom. First you give the numbering first. 1, 2, 3, 4, 5, 6. Right, our question what it is, you have to take a triangular face, you have to take a triangular face in which 2 chlorine atoms and 1 nitrogen should be there. 2 chlorine atoms, 1 nitrogen should be there. So here what happened, 2 chlorine atoms, 1, 2, 1, 3 you have to take, 1 comma 3, right, 1 comma 3, and 1 nitrogen atom means this one will come, right, 1, 3, 4, 1, 3, 1, 3, 5, like this manner you have to take 1, 3, 5, 1, 3, 6, and 1, 3, 2, 1, 3, 2, this one 1, 3, 2. So total 4 faces are there, right?